Hello kids, today we will be discussing about some special sequences. To start with, arithmetico-geometric series. Consider the arithmetic progression a plus d, a plus 2d, etc. What will be its nth term? A plus n minus 1 into d, and the geometric progression 1, r, r square, etc. up to r power n minus 1. Here I have kept the first term of geometric progression as 1. Now I am going to form a series S n equal to. First term I will take as a product of these two, that is a plus d into r plus a plus 2d into r square plus etc. Last term, nth term, a plus n minus 1 into d r power n minus 1. The series thus obtained is called arithmetico-geometric series. So, how do we get an arithmetico-geometric series? By multiplying corresponding terms of arithmetic progression and geometric progression. Let us see how to find sum to n terms of the series. Here geometric progression is 1 r square etc. What is its common ratio? Common ratio of the geometric progression is r. I am going to multiply both the sides of this equation by common ratio of the geometric progression. Left side is r into Sn equal to ar plus a plus d into r square plus etc. Last term, when you multiply by r, it will be a plus n minus 1 into d r power n. Now, subtract the second equation from the first. Sn into 1 minus r equal to ar will get cancelled. What will be left here? dr. Similarly, ar square cancel ho gaya, dr square plus etc. The last term would be minus of ungrouped term a plus n minus 1 d whole power n minus 1. Now you follow the series dr. Again. Repeat. I am going to subtract the second equation from the first. Sn into 1 minus r equal to a plus dr plus dr square plus etc. Can you see the last term? Minus of, it is ungrouped, a plus n minus 1 d into r power n. Can you see the term just before this? See the pattern dr square etc. The term just before the last term would be dr power n minus 1. Now, leave the first and last term of the series. You have a geometric progression whose first term is dr, common ratio is r, and you have n minus 1 terms. Apply sum to n terms of geometric progression. Sn into 1 minus r equal to a plus. What is sum to n terms of a GP? A into 1 minus r power n divided by 1 minus r. Putting the formula here, dr into a into 1 minus common ratio is r power n minus 1 divided by 1 minus r, then minus a plus n minus 1 d into r power n. This is Sn into 1 minus r. From here we get Sn, divide both the sides by 1 minus r, a by 1 minus r plus dr into 1 minus r power n minus 1 divided by 1 minus r whole square minus a plus n minus 1 d into r power n divided by 1 minus r. This is sum to n terms of this arithmetico-geometric series, this AGP. Now, if we have to find sum to infinite terms, I will do the calculations here. if we have to find sum to infinity of this arithmetico-geometric series under the condition mod r less than 1. If common ratio of r lies between -1 to +1 excluding 0, how to find sum to infinity of this arithmetico-geometric progression? In this case, that is, we are going to find limit n tends to infinity of r power n. Can you say what this value will be? Modulus of r is less than 1. So, this will be 0, putting the value in that sum to infinity. Sum to infinity is given by S equal to first term a by 1 minus r, which is independent of n. So, I will write as it is a by 1 minus r plus next term dr, no problem, 1 minus, look, r power n minus 1 you have, and limit n tends to infinity of r power n is 0. So, n tends to infinity of r power n minus 1 also will be 0. So, I will write 0 divided by 1 minus r whole square minus. See the next term. Here we have a term in r power n that will reduce to 0. So, minus 0. So, we get sum to infinity of an arithmetico-geometric series as a by 1 minus r plus dr divided by 1 minus r whole square. This is sum to infinity of an arithmetico-geometric series. But when I started, I have said I have taken the first term of GP as 1. If it is not 1, suppose the GP is like this. First term I am taking it as B, second term will be BR, third term will be BR square, etc. Last term will be B into R power n minus 1. You can proceed in a similar manner to find sum to n terms and sum to infinity. That is left to you as an exercise. The only difference in the answer will be each and every term will be multiplied by B. एक बार आप करके देखो. The first term of geometric progression, if we take it as B, that is the geometric progression is B, BR, BR square, etc. Then Sn, the only difference will be instead of A by 1 minus R, it will be AB 1 minus R. Second term dr के जगह drB into बाकी as it is, and third term again it will be multiplied by B. Same is the case with sum to infinity. Each term will be multiplied by B. Is it clear, bete? First question. Find the sum of the series to n terms. Let us check first which type of series it is. Each term is product of two numbers. I will write over here the series first term 1, 3, 5, 7, etc. You can see that this is an arithmetic progression. Then 1, x, x square, x cube, etc. This is a geometric progression. We have to find sum to n terms of this series. That means you have to find the nth term. What will be the nth term? It will be the product of nth terms of arithmetic progression and geometric progression. So, let us find the nth term of this arithmetic progression. A plus n minus 1 into d, the common difference is 2. So, it is 2n minus 1, and geometric progression it is a into r power n minus 1, which will be x power n minus 1. So, let us write the series as Sn equal to 1 plus 3x plus 5x square plus 7x cube plus etc. plus nth term. It is the product of nth terms of these two terms, which will be 2n minus 1 into x power n minus 1. अब आप बता सकते हो what's the next step? We have to multiply both the sides by the common ratio of the geometric progression. We have geometric progression here 1x, x square, etc. So, its common ratio is x. Multiply both the sides by the common ratio, x into Sn equal to, like terms together, 1 into x I am writing here, plus 3x into x, 3x square plus 5x cube plus etc. Last term 2n minus 1 into x power n. What's the next step? Yes, subtract the second equation from the first. Sn into 1 minus x equal to 1 plus 2x plus 2x square plus 2x cube. You can see these terms, they form a geometric progression, and the last term which is ungrouped 2n minus 1 into x power n. Leave the first and last term. Why we should leave? Because they are ungrouped terms. Generally, they will not be a part of this progression. We have a series of n minus 1 terms here, leaving the first and last, whose first term is 2x, geometric progression and common ratio equal to x. So, Sn into 1 minus x equal to 1 plus sum to n terms of GP. Write the formula here, a into 1 minus r power n divided by 1 minus r. Put the values. A is 2x, a into 1 minus r, common ratio, power, number of terms n minus 1 divided by 1 minus x, and then the last term minus 2n minus 1 x power n. This is the value of Sn into 1 minus x. We have to find Sn equal to dividing by 1 minus x, 1 by 1 minus x plus 2x into 1 minus x power n minus 1 divided by 1 minus x whole square minus 2n minus 1 x power n divided by 1 minus x. Is it clear, bete? From this series, if this condition is given mod x less than 1, we can find sum to infinity. जैसे हमने पहले किया, if mod x is less than 1, then limit n tends to infinity of x power n. This we can take it as 0. So, this term will be 0, 0 here, x to the power n minus 1. So, sum to infinity will be s equal to first term independent of n as it is 1 by 1 minus x plus 2x into wherever we have x to the power n, x power n minus 1 etc. As n tends to infinity, such terms will reduce to 0. So, here 2x into 1 minus x power n minus 1 as n tends to infinity will be 0 divided by 1 minus x whole square, and third term, since x power n is present, 2n minus 1 into 0 by 1 minus x. It will be 0, which is sum to infinity of the arithmetico-geometric progression given 2x divided by 1 minus x whole square. Is it clear, bete? Shall we proceed to the next question? Next question on the module. Question is written on the board. You have to find the value of 3 power 1 by 4, 9 power 1 by 8, 27 power 1 by 16 etc. up to infinity. I'll rewrite the series 3 power 1 by 4. 9 can be written as 3 square power 1 by 8. 27 is 3 cube power 1 by 16 etc. goes on and on up to infinity. Look, here the bases were different, 3, 9, 27. What I have done is, by writing 9 as 3 square, 27 as 3 cube, we get same base, which can be written as 3 power 1 by 4 plus 2 into 1 by 8. Let's write it as 2 by 8 plus 3 by 16 plus etc. It is an infinite series. What we have to do is to find sum of this infinite series. So, for the time being, I am denoting it as s. अब s की वैल्यू निकाल के वापस हमें इसमें डालना है. Let's calculate the value of s. S is 1 by 4 plus 2 by 8 plus 3 by 16 plus etc. up to infinity. बता सकते हो बेटे what type of series it is? सम टू इन्फिनिटी ऑफ एन अरिथमेटिक और ज्योमेट्रिक सीरीज. फॉर्मूला याद है तो कर लो, अदरवाइज 1 मिनट लगेगा कैलकुलेशंस करने में. S is given by 1/4 plus 2/8 plus 3/16 etc. up to infinity. What's the step? Multiply by the common ratio. What's the common ratio? 1/2. Multiplying 1/2 S equal to 1/4 into 1/2, 1/8, 2/8 into 1/2, 2/16 plus etc. up to infinity. Next step, subtract equation number 2 from equation number 1. Subtracting 2 from 1, S into 1 minus 1/2 equal to 1/4 as it is, plus 2/8 minus 1/8, 1/8 plus 1/16 plus etc. up to infinity. Look here, S is an infinite AGP, arithmetic or geometric series it is. After calculation, we got sum to infinity of a geometric series. Formula yaad hai? A by 1 minus R. Apply the formula. S into 1/2 equal to A is 1/4 divided by 1 minus common ratio of the geometric progression 1/2, which simplifies to 1/4 into 2/1, that is 1/2. So, S into 1/2 equal to 1/2. What does it give? S equal to 1. Now, put the value of this S over here. हमें calculate करना है 3 power 1/4, 9 power 1/8, 27 power 1/16 etc. We have calculated, we have simplified it to 3 power S, got the value of S as 1. Put the value 3 power 1, which is equal to 3. देखो which option is matching? Option A. It's a very simple question. I hope it is clear to you. Shall we proceed to the next one? Question number 3 on the module. It is double summation. Double summation sigma m equal to 1 to infinity, sigma n equal to 1 to infinity, m square n divided by 3 power m into n 3 power m plus m into 3 power n. Look how to solve it. Very good question it is. Sigma m equal to 1 to infinity, sigma n equal to 1 to infinity. Listen carefully how I am going to solve this question. Numerator is m square n. I am going to bring this numerator to the denominator. So, 1 divided by, ये बन गया 3 power m, n into 3 power m plus m into 3 power n. Denominator will be m square n, 1m. I'll write here, बाकी जो mn है that for this bracket. So, the first step, numerator you write as denominator's denominator. और उसको अलग अलग किया हमने 3 power m के denominator m and inside the bracket we have taken the remaining m. Let's do the calculations. M equal to 1 to infinity, sigma n equal to 1 to infinity, 1 divided by 3 power m divided by m into n and n will get cancelled. First term 3 power m divided by m, इसमें m m cancel हो गया, 3 power n divided by n. Now, just to make the calculation simple, I am taking 3 power m divided by m as am and 3 power n divided by n, I take it as an. So, this becomes m equal to 1 to infinity, n equal to 1 to infinity, 1 divided by 3 power m divided by m, I have taken as am into am plus an. So, we have simplified the given sigma to this one. I will call it as equation number 1. Now, I am going to replace m by n, replacing m by n. So, becomes sigma, पहले m लिखो बाद में लिखो, it's one and all the same thing. So, I'll write it as m equal to 1 to infinity, sigma n equal to 1 to infinity 1 by an into an plus am. For the calculation, I'll take it as S. So S again is this. ये हो गया equation number 2. Now, add equation number 1 and 2. Calculations over here, adding 1 and 2. Equation number 1 plus 2 gives. Left hand side is S plus S. S plus S will be twice of S equal to m equal to 1 to infinity sigma n equal to 1 to infinity of. Calculations करके बता सकते हो बेटे what you get? 1 by am plus an. I'm taking out, then you are left with am plus 1 by an. Take LCM and simplify to get the value of 2s as m equal to 1 to infinity, n equal to 1 to infinity, 1 by, after taking LCM it will be am plus an cancel हो गया, only am an is left, that too in the denominator. Now replace am and an by their values. Sigma m equal to 1 to infinity, sigma n equal to 1 to infinity, 1 by am is 3 power m divided by m into 3 power n divided by n. So 2s is sigma m equal to 1 to infinity, n equal to 1 to infinity, m n divided by 3 power m into 3 power n. Now listen carefully. Double sigma two types के होते हैं. Here m equal to 1 to infinity, n equal to 1 to infinity अलग अलग दिया है. That means these two sigma they are independent. What I am going to do is I am going to separate the terms here. That is we can write it as m equal to 1 to infinity. इसके साथ खाली m वाले terms collect करो. m divided by 3 power m into next sigma n equal to 1 to infinity of, collect all the terms in n and write in the sigma n divided by 3 power n, which is the value of 2s. Now we have to find the value of these two sigma, that is sigma m equal to 1 to infinity of m divided by 3 power m. Calculation is left for you. ये evaluate करो, इसके answer आ रहे 3 by 4. Do check it. We have done 2 questions of this type. अब आप अपने आप करो. Similarly, second sigma also will be 3 by 4. So 2s equal to sigma m equal to 1 to infinity. I am putting, so 2s equal to, putting the value 3 by 4 into 3 by 4, which simplifies to 9 by 16, but it is the value of 2s. So s will be equal to 9 by 32. Look, which option is correct? Is this option present? No. That means answer is option D. Answer is option D. देखो, it's a very good question. Whenever questions of double sigma are there, as I told you, 2 types are there. In this case, these two sigma they are independent. M की value अलग दिया है, n value is given separate. So what I have done is I tried to separate the terms in m and n like this. इसमें mix करके दिया है. इसको अलग करने के लिए I have taken this term to the denominator और इसको अलग किया है, right? And calculation के लिए 3 power m by m को am denote किया है and an I have taken it as 3 power n by n. After that, note this step also. After that, interchange m and n. इसमें m and n को interchange करके you form a fresh equation after interchanging m and n. इन दोनों को add किया है. After adding, we get the sequence so that in which m and n are being separated. उसके बाद 2 infinite series है हमारे पास. AGP सम निकाल के वापस इसमें डालना है एंड फाइनल आंसर s इज इक्वल टू 9 by 32. इस क्वेश्चन को अच्छे से प्रैक्टिस करो बेटे. विल प्रोसीड टू द नेक्स्ट क्वेश्चन. नेक्स्ट क्वेश्चन ऑन द मॉड्यूल. क्वेश्चन इज रिटन ऑन द बोर्ड. Read the question. The sum to n terms of this series. Series given is 1 square minus 2 square plus 3 square minus 4 square plus 5 square minus 6 square. Examine the series closely. All even terms 2 square, 4 square, 6 square, they are in negative, and odd terms 1 square, 3 square, 5 square, they are in positive. That means unless and until we write the last term, we can't solve it. So, two cases arise. Case 1, I will take n to be even. If n is even, series becomes 1 square minus 2 square plus 3 square minus 4 square plus 5 square minus 6 square plus etc. Last term is negative minus n square. Reason क्या बेटे, हमने n को even लिया है. All even terms they are negative. Can you say the preceding term? N minus 1 the whole square. Now I am going to pair the terms. First, second, third, fourth, fifth, sixth, and then the last two. Each of these brackets, they are of the form a square minus b square, a plus b into a minus b, 1 plus 2 into 1 minus 2, 3 plus 4 into 3 minus 4, 5 plus 6 into 5 minus 6 plus etc. Last term will be n minus 1 minus n into n minus 1 plus n. Each term reduces two factors, of which one factor is minus 1, minus 1, minus 1 and minus 1. So, I am taking that minus 1 common, minus 1 into what we are left with, 1 plus 2 plus 3 plus 4, 5 plus 6 etc. up to n minus 1 plus n. Can you say the term inside the bracket? 1 plus 2 plus 3 plus etc. up to n minus 1 plus n, which is sum of first n natural numbers. Sum is given by formula batao bete, n into n plus 1 divided by 2, which simplifies to minus n into n plus 1 divided by 2 is the sum of the given series when n is even. Out of the two cases, only one case we have discussed, when n is even. Second case, when n is odd. The series becomes 1 square minus 2 square, 3 square minus 4 square plus 5 square minus 6 square etc. N is an odd number, last term plus n square, n minus 1 the whole square will be minus, and n minus 2 whole square it will be plus. अब देखो n is an odd number. What can you say about n minus 1? N minus 1 is even. If n is even, already we got the result. If n is even, the sum is given by minus n into n plus 1 divided by 2. Here n odd, n minus 1 is even. So, we can apply the result for n minus 1. Collecting these many terms, I am going to apply the result which we have proved earlier for n minus 1 terms. Reason क्या है? N odd, n minus 1 even, putting the value minus. Result is n into n plus 1 divided by 2, n की जगह n minus 1. So, it becomes n minus 1 into n divided by 2, that is this collection plus we have n square. Only simplification is left, 2 is LCM, minus n square plus n plus 2n square, which simplifies to n square plus n divided by 2 or n into n plus 1 divided by 2 when n is odd. Let us see what exactly we have done. The given series is 1 square minus 2 square, 3 square, minus 4 square plus etc. Since the last term was not given, two possibilities arise. One is when n is even, n is odd. n is even, हमने series closely देखा है, all even terms here they are negative, so we have taken the last term to be minus n square, paired the terms, factorized, simplified, got this one. अब second case में we are going to use this result क्योंकि हमने already prove कर रखा है n even है तो sum is given by minus n into n plus 1 by 2. Second case में n odd, n minus 1 even होगा. So apply this result for the first n minus 1 terms becomes minus of n minus 1 into n by 2, and the last term I have written like that only, plus n square, after that the calculation. So let us fill the blank. When n is odd, what is the sum? N into n plus 1 divided by 2, and when n is even, it is minus n into n plus 1 divided by 2. Is it clear? Okay. I hope you understood all the concepts and questions which you have discussed today. Do the solved examples again, do the questions given in the exercise. If you have any problem, come back to us. Thank you.